Hello everybody, my name is Chris Brady, all through the Boeing 737 Tech Guide and the Boeing 737 Tech site, and this video covers the 737 FMC updates 10.6 to 10.8A. So as you probably know, this is one in a series of 4 videos covering the FMC updates 10 through to update 14. I would say that even if you're using update 14, this video will still be relevant, as all of the features that were introduced here between 10.6 and 10.8A are still actually current on update 14. So I say don't think that this is of no relevance to you if you're using a later update, as it will be. Perhaps also worth mentioning for those of you that might have missed it, that I've also done a video on the FMC itself as opposed to the software. This was done a few months ago, and it covers the FMC hardware, the CDU, annunciations, inputs, databases and maintenance pages. So perhaps worth a look at if you haven't already seen it. Okay, so on to 10.6. It was released in August 2005, and it replaced 10.5A that had been released in the previous year. Some of the features that were introduced with 10.6. First one was that it added performance data for the 737-300 and 400 with winglets, which had only just started coming in then. Another tweak that was made, the select a desired waypoint page. Now this goes back to the very first version of the FMC, and the only previous tweak to it was in 10.0, when it was expanded to take a maximum of 12 waypoints over 2 pages. What this does is it changes the title, which, again, for those of you who didn't fly the 737 before 2005 will probably not know this, but this page used to be called Select Desired Waypoint, WPT, but now it helpfully, if it actually gives the ident name. So in this example, it's Papa Oscar Romeo. Now that we know, but what the second change that was brought in is what's shown in the photograph, and I have to confess this is a mock-up, and I hate doing mock-ups of photos. I always like to give you an original, genuine photo, but I couldn't find one. Although the feature was introduced in 10.6, I have reached out to so many people who fly the 73 for other airlines, and nobody had this feature. But you can see I've mocked it up there, where it actually writes the ARINC 424 name characters, so the actual name of the ident. So Porto Alegre or Porto Ros for the VOR DME, even though they're both, the ident for both is Papa Oscar Romeo, they've got a different name. Now I can only assume that although the feature did come in 10.6, most airlines elected to not include the names in the nav database because it would consume too much space. That's the only logic I can see to this. So although it would be helpful to us to have the actual real name, I know for a fact that nav database space is an issue, particularly with airlines that fly, beyond one continent. And of course with longer range 737s, more particularly the Max, that is an issue, or a consideration, I should say. So so the named function, although it was introduced and made available in 10.6, I've never actually seen it. As usual, if anybody has an example of this, then please send it in to me. I'd love to see it. Okay, next feature was flight path angle arrival field. Something we all take for granted today, but pre-2005 it wasn't there. You could construct an extended centerline for a runway, but you couldn't declare the flight path angle for it. With 10.6 you could, and of course that, as we know, propagates forward to the legs page, where whatever FPA you put in is shown there as, oddly enough, as a glide path, even though it isn't necessarily a glide path. Additional fixed pages. This is an option, which means your airline, if it wants it, has to pay for it, which is why possibly many of you may not have seen this feature, even though it's been in for, what is it, 17 years. The default number of fixed pages is 2. For the appropriate fee, your airline can up that to 6, which an airline I was with did, and there you can see the example of it. It's one of those, if you use this, and again I used to use it to mark out my alternates as I was flying, then it's great, and can be really useful. But if you're not somebody that does that, then you probably wouldn't see the need. A QRH takeoff speed check was added, and again there have been several of these going back. That this is a further development and a further layer of speed checking, and this is just the straightforward one, that the V1's less than VR and VR's less than V2. If the entered speeds don't meet those criteria, then your speeds will be deleted. Geometric path descent was made basic in 10.6. This caused uproar. Although I've shown the FMC page there showing it as an option, which perhaps a bit misleading on me. It was actually changed from optional to basic, so the airlines had no say whether this was the way descents would be done or not. And you can see on the graphic there just to reiterate for those of you who may have missed what a geometric path descent is, as opposed to a standard, fly level until you intercept the standard idle thrust descent profile. Geometric path basically just connects a line between two altitude restrictions and flies that. So it's the point is, it's not idle thrust, which confuses pilots and air traffickers alike if that's not what's expected. It's becoming more popular now. Everybody's got used to it, but back in the day, this really was an issue. So actually, I'll come on to it later on in 10.7. This was made optional again, just to keep us all happy. Common VNAV option. This is an option, so it isn't standard, although it is actually standard on all other Boeing types, which is where the word common comes from. So what it does is it removes the selectable speed or path descent mode options, and the speed and path designation from the page titles. So econ path descent, for instance, would just become econ descent, or econ speed descent would just become econ descent. Also, the reversion mode for a path descent to prevent an overspeed condition is actually now VNAV speed. It used to always disconnect and go to level change, but with this option it'll just change to the elevator reversion mode will go to VNAV speed, and also when or if the descent path is recaptured within the tolerance of energy limits, the mode will change back to VNAV path. So quite big changes there. I'll say it was optional at this stage. Speed propagation option. I have to say that this is one of those that I think is quite mean of Boeing to make an option and not standard. Again, just to remind you that options do have to be paid for. But why on earth this wasn't made standard, I don't know. But what it was, if you enter a speed in the cruise, so if you change the cruise speed, what it will do is it will very helpfully for you. It will propagate that on to the descent page, and that prevents that sudden sort of disjoint of speed changes when you transition from the cruise to the descent. So in this example, I've shown you if air traffic have asked for 280 knots, or you want to do 280 knots, then that's what will propagate forward onto the descent page. Altitude intervene, for those of you who've got it. The logic was revised to prevent the inadvertent deletion of altitude restrictions on the approach by pressing the Alt Intervene button. This was done for RNAV operations, basically, and it was to save us, really, for those of us with fat fingers. If you were trying to change the altitude there, you might accidentally, your finger might just brush up against the Alt Intervene button, and you could inadvertently delete the next altitude restraint. Now, if that was on the approach, then that could have implications if you're doing an RNAV approach. So, as a safety barrier, Boeing redesigned it so that altitude restraints which are on approaches, so not ones that are out in the terminal area, but approach altitude constraints can now only be deleted through the CDU, which I say is quite a helpful feature for us. LNAV go around. So again, another one we probably take for granted now, but this was brought in with 10.6 in 2005. So this option enables the aircraft to stay in LNAV instead of track following a go around. When a missed approach is in the flight plan and the flight control computers are armed for go around, then LNAV arm will be enunciated there on the FMA. If toga is pressed with LNAV arm enunciated and flare arm is enunciated, so in other words you've got a dual coupled ILS approach below 1500 feet, then LNAV engages at 400 feet rad alt. Below that altitude, it's track hold. So the sequence will be you press toga, it goes to track hold, and then at 400 feet it transitions through to LNAV. If you're doing a single channel ILS, so in other words flare arm is not enunciated, then LNAV engages at 50 feet rad alt. So below that, there is much space below that, but you get track hold. So that's the difference between a dual coupled ILS and a single channel ILS. Bank angle on LNAV was reduced to a half track change with a minimum of 8 degrees and a maximum of 23 degrees, and previously been 25. So you can see the magenta line there on the graph is the previous one, 10.5, and the red line is 10.6. So there's been a reduction in bank angles brought in, and this really is to just improve altitude capability. I mean, the greater the bank angle, the less the vertical component of lift, and if you're right up to at optimum or maybe above it, but slightly below max altitude, then that could have an impact on your altitude capability. And I say these limits are just for en route. They not the reduced bank angle isn't applicable for procedure turns, holds, or procedure holds or holding patterns. So it's just en route. The yellow line there is the DO236. I think it's version A. What this is, and if you ever are having difficulty sleeping, then Google and download this document. It's the minimum aviation system performance standards for RMP area nav. So it's a real chunky document that lists all the standards and criteria that aircraft and on-nav approaches have to meet. So basically, this is still compliant, but it's reduced the bank angle limits. And uplink delay timer field was added to the log on status page for so basically you can now set the maximum delay duration between 1 and 999 seconds as directed by ATC. So air traffic will give you the figure. You don't just randomly put one in yourself. So what this is used for, it's used by the FMC to tell you if a data link clearance is older than a voice message that was sent to replace it. That's what it does. If that happens, then you get a scratchpad message of uplink delay exceeded, and you'll know to disregard that last clearance. This page was actually revised later on with update 14 when FANS 2 came in, but this is if you like the FANS 1 version of that. Other refinements and bug fixes that came in with 10.6, the engine out SID logic was revised again to find if the active waypoint is one of the waypoints in the engine out SID, so it could connect seamlessly. VNAV logic was changed to prevent nuisance VNAV disconnect messages during landing, which was very much of an irritant in the early days of the NG. Dual FMC enhancements will let two FMCs continue to operate when there are disagreements between them. Now I've put the See My FMC video for more details. I'll also mention it later on in this video as well. Errors in ETA and fuel remaining predictions were corrected, and you can stay in quiet climb when data relating to v-speeds is re-entered. So a few tweaks there. Okay, on to 10.7. This was released in March 2007 and replaced update 10.6 that had been released 2 years earlier. So 10.6 actually was quite a successful update. It survived 2 years without an update or the need for a 10.6A. So it proved itself to be quite bug free. So they managed to get 2 years out of that one, which is quite impressive. Anyway, it contained new features, most of which I would say were navigational, and a few bug fixes for 10.6, which had resulted in some FCOM bulletins, which I'll go through later on. The first change was to the way altitude capability was calculated. So up on the top left, that's the perf init. That's what happened pre 10.7. So the forecast top of climb, which you would enter as part of the pre-flight prep, is used for the pre-flight planning forecast of both the optimum and max altitudes. With 10.7, the calculation was updated in flight. This was a significant difference. When you climb through 5,000 feet above departure runway elevation, then 10.7 would actually start using the actual ISA deviation, which is derived from the sense SAT, to continually recalculate the optimum and the maximum altitudes. So in other words, it gives us a much more accurate optimum and maximum altitude figure. For what it's worth, below 5,000 feet, the pre-10.7 temperature model is still used. In other words, the figures from perf init. An AMP comparison was added. So in dual FMC aircraft, which should be most of them these days, the AMP was always calculated independently by each FMC. Well, I say is actually still always calculated independently by each FMC. In previous updates, each AMP was actually shown on its own on-site CDU and ND, and they could therefore be slightly different. So, you know, you in the left-hand seat could have one AMP, and the guy in the right-hand seat could have a different AMP, which would give an unnecessary level of doubt into your minds as to what the actual AMP was. Which, of course, if you're on approach, you know, is a significant issue. I mean, they wouldn't be out by much, but for instance, if one was within limits and one was beyond limits, then what do you do? Anyway, Boeing and Smith sorted this out, and what they said was, even though each FMC will still independently calculate AMP, only the larger figure will be displayed on both CDUs and NDs. So that's good for us. It's on the safe side, and it takes that element of doubt away for you know, what do we do about this situation. The vertical AMP calculations were revised in 10.7. Previously, vertical AMP calculations were apparently made with data that could have been too conservative, and some in-service vertical RMP alerts could have been the result of simply how it was calculated, rather than being a genuine exceedance of AMP. With 10.7, the vertical AMP is now going to be calculated, or is now calculated with Mach to get a more accurate vertical AMP. And analysis of the result of the new formula and the use of Mach is that vertical RMP alerts for operations at VRMPs of less than 200 feet have gone down. So in other words, accuracy has improved with the new formula and the use of Mach. The right now, the RMP boundary has always been circular. As you would expect, it's a distance, it's a figure, it's, you know, 0.1 or 0.2 or whatever the heck it might be. It's a circle around the aircraft. Well, this was tweaked slightly for the GPS figure. So lateral AMP calculation was revised to use an elliptical threshold to mitigate a thing known as GPS data latency. So what this is, it's a very slight difference in GPS time tag and the FMC clock. So GPS data is time tagged, and the FMC's got a built-in clock. If the FMC sees a difference in those two, then it will throw out the AMP calculation. What has been done is the RMP boundary has actually been stretched by 2 seconds flight time ahead and behind the aircraft to compensate for this thing known as, I say, GPS latency. The cross-check boundary is unchanged because the aircraft's not moving cross-check very fast, but it is, you know, it can move, you know, forwards and backwards quite track and accelerate as well. So the cross-track boundary is unchanged, but the on-track, i.e. the flight path boundary, has just been stretched out by enough to take away any I'll say random, any undesired errors in GPS data latency. The accuracy is still there. You know, it's a computing issue rather than you know, fudging the figures to make things work. And it was done to reduce the number of nuisance alerting messages, and it was successful. So that's what was going on there. Some new position discrepancy messages were added. In fact, many were added, 6 in actual fact. Before 10.7, all we used to get was verify position, which is, well, can be quite a big ask really. What 10.7 brought was more definition as to what particular position needed verifying, because as we know there are many different positions: IRS, FMC, radio, GPS, and or any combination thereof. So now it actually specifies verify position IRS or IRS FMC, or IRS radio, depending which are where the error is thought to be. On ground possibilities, we've now got IRS position origin disagree or FMC position runway disagree, and it basically enables us to troubleshoot more effectively what the problem could be. GPS invalid alert is now given if the GPS data is missing or invalid for 30 seconds in flight or 10 minutes on the ground to the FMC. It used to be instantaneous, which was a little bit ridiculous, because signals can go in and out just for a split second. So what it's done is it's given an acceptable buffer for those. The message can either indicate a fault in the GPS receiver, in which case it may not come back, and then action needs to be taken, or that there's no data available, and option C is the common one these days, due to a satellite outage or shielding of the signals. And again, I come back to this: in certain parts of the world, particularly around the Middle East, that there is GPS satellite shielding going on, and this can last for various amounts of time. And if it's only a momentary one, then you won't see this scratch pad message. If it lasts for more than 30 seconds in flight, then you will. There were also new, these were to support RMP procedures, so that you knew whether it was safe to do an RMP approach or not. Lock update inhibit, and again this kind of goes back to the previous slide about GPS updating. So lock updating is now automatically disabled when the FMC is GPS updating, because GPS updating is by far and away the most accurate way of position updating. We still have the ability to inhibit or allow lock updating of position via the nav options 2 page, so we can still select this if we wish. But the benefit of inhibiting lock updating is that in the event that the GPS updating becomes available because of, say, satellite unavailability, it allows the FMC to use its derived compensation for the ADIU drift for the nav solution, and this is much more accurate than using lock updating. Again, this comes back to the fact that nav position calculation and updating is much more of an accurate science than it used to be back in the old days when we were relying on nav aids. The algorithms for calculation have become much more refined, and previously it would have been better to use, I don't know, either DME update or lock update. It now no longer is, and the specific reason why lock update is not particularly accurate is because most facilities record localizer courses in 1 degree increments, instead of the 0.1 degree increment that the FMC needs for precise position updating. So it is at a 10th less accurate, or 10% less accurate than to use lock updating than it would be to use, say, the compensation for ADIU drift. So that's why it's done. And if you wish to update this way, you can manually select it, but the advice generally is not to, and leave the FMC to do its own calculations its own way. The unable required performance RMP message, which of course is extremely useful if you're on an RMP approach, an RNAV approach, will now display on the nav display in addition to the CDU scratch pad whenever this condition exists. And this is purely to be an attention getter to alert you if you're on an RNAV approach that you now no longer have the accuracy, and you need to go around or whatever your decision is to do. Alert times display. The unable required perf nav, perf RMP time to alarm values. These are the figures that will flash up an alert if you're beyond the RMP. So the times for these can now be changed via the software, the operational program config software, rather than having to use the Smith's default figures. You as an airline can now change these figures if you wish. The new default values are now shown on the software options 1 page. Pre 10.7, the default values were both longer at 80, 80, 60 and 10, and were also not displayed, so it was kind of a bit of a secret what they were. But now they're displayed, and as I say, your airline can change them if they so wish to. The minimum econ descent speed it's been reduced. Pre 10.7, the minimum econ descent speed was 250 knots, and this figure was selected to. So I've written to assist ATC, so it's not to not to be too slow in the skies, and not to have ATC on your case. With 10.7, this speed was extrapolated down to 238 knots at cost index 0. And it can be further reduced down to 180 knots in RTA mode. So just be aware, if your airline policy is or you choose to select cost index 0, say if you're tight on fuel or something, the minimum econ descent speed will come back to 238 knots. So it may be worth sort of clearing that with air traffic first. In RTA mode, it doesn't matter, because we use this if we're told to expect a delay at a certain hole before or to meet an RTA, then sure that air traffic are expecting you to fly whatever speed you need to achieve that. But just be a little wary of cost index 0 post 10.7. The graphs there from the Flight Plan and Performance Manual. A point of trivia on the MAX: this speed actually also varies with weight, as they've refined the calculations. VNAV display. This is now always displayed whilst in a descent mode with 10.7. Previously, it didn't display if you'd selected an early descent. Speed constraints. Pre 10.7, you could only set at or below speed constraints on the legs page. There's an example of a below one there with the capital B after the speed. 10.7 brought in the facility to enter at or aboves with the A suffix, which I've shown on there on the legs page. Don't very often use them, it has to be said, but can be useful if you got speed control and want to remain in VNAV to stay on the correct vertical path. So there you are, the options there. I guess it was quite an easy thing to program in. Now, as a result, perhaps of this increased speed flexibility, or programmable speed flexibility in the legs pages, 2 new speed constraints messages or alerting level messages were added. Unable whatever not at a certain position when the next waypoint speed restriction can't be met. That's the one shown there on the upper photo. And drag required after whatever waypoint, and that would be displayed when the speed constraint is greater than 10 knots above the predictive speed. VNAV on before takeoff. So with 10.7 and CDS block 0.6, so that's the software update for the display systems, and with the Collins Autopilot on software 4.0 or later, or Honeywell 710 or later. So with all of those particular other criterion, you can now arm VNAV and LNAV independently prior to takeoff. If VNAV is on prior to the flight director takeoff activation, and the VNAV arm annunciation will appear, and VNAV will engage automatically at 400 feet. With LNAV, LNAV will engage at 50 feet. So there's a slight difference in engagement height with the two things, which you should be aware of. But the point is, you can now arm VNAV. Takeoff ref page. This was extensively changed. Again, like all changes on pages we use a lot, it did have us searching for the information for quite a while, for several months after this came in. So the pre-update 10.7 is shown on the top picture, and 10.7 onwards is shown in the bottom photo. So the first thing it did was it included the all engine and engine out acceleration heights, which are shown there in red. The second thing it did was it shifted over to the right the selected and OAT field. That was to accommodate the acceleration heights. The third thing it did was it deleted the takeoff M1 field, because that was already there on the takeoff ref 1 page and the M1 limit pages. So it was actually redundant being in that position. Now, a word on the minimum heights, which are shown on this takeoff ref 2.2 page. The acceleration height and the engine out acceleration height, you can change these, and standard logic it will go to large font when you do, as you can see I've done here in this photo. You can change these down to a minimum of 400 feet. However, the thrust reduction altitude can only go down to 800 feet, and you can see here I've tried to put in 799 just to show you it's given me an invalid entry. So 800 is the minimum, and in this case the default, because it's in lowercase. So if you want to use an all engine acceleration height below 800 feet, such as the 400 feet I've put in here, just be aware that automatic thrust reduction will not occur till 800 feet. So the aircraft will pitch down and accelerate at 400 feet, but still with takeoff thrust, which you may not want, and you may want to be aware of your flap retraction considerations if in that case. Now, if you want to, you can lower thrust. If you want to lower thrust reduction, you can do so, but you've got to do it manually. That's all I'm saying. I mean, that the chance of using such a low acceleration height and needing this, probably limited to very, very few airfields and types of operation. But this is just worth thinking about. The flaps and leading edge device limit speeds are now sort of known by the FMC and consideration taken. So the FMC target speed, in other words, this actual, and in this case 230 limit climb, is now limited to 5 knots below the flat placard speed. So if you're taking off at, say, I don't know, flap 25, this will show 195. This helps prevent flap overspeeds. For example, when the aircraft is accelerating up to 250 knots after takeoff. The flap placard speeds are hard coded for the classics, and they're actually in the model engine database for the NG and the Max. Also for the NG and Max, the FMC target speed is limited to 230 knots until all leading edge devices are retracted, as you can see in this photo here. This feature requires CDS Block 0.6, which everybody should have now. Takeoff thrust auto select. This is not actually a particularly common option. So this might be new to you to see this, but basically this allows the FMC to auto select an appropriate D rate based on your airline's policy and the airport runway combination entered by yourselves when you're setting up the FMC. So you can see a list of the defaults by pressing the next page button from the M1 limits page, and the thing to note here is that the M1 limits page goes up to 13 pages. So there's 13 pages of database in this particular scenario, showing numerous airport and runway combinations. So let me go into that in a bit more detail here. So possible, if you notice on the photos, you've got an airfield, then either a 3 X's or a runway, and then a number. Those numbers are your thrust selections. So possible options for those are 0, which is full thrust, 1, which is takeoff 1, D rate 1, 2, which is takeoff D rate 2, or B, which is bump. The first entry on the first page of these thrust settings, so not the M1 limit, which is the page 1, but on the takeoff thrust settings page, which is page 2 and onwards. So the first entry on page 2 is always the default, and you can see here that the default, and therefore all, is for this airline they have chosen 0, which is full thrust. So the default is full thrust. That means if the airport and runway is not one that is listed on the next 12 pages, the default figure will be, the default thrust will be full thrust. If they now, if you look ahead on these examples here, I've highlighted a few cases. So any short or climb limited runways, like and if you look down at the bottom right there, so Sierra Bravo Bravo Echo runway 0624, that is using 1, that is using takeoff 1. So the Sierra Bravo Bravo Echo has also got a runway 0220, which is 1830 meters. That has not been specified, and it's not been specified because for a runway that short, it assumes you will want to go full thrust, which is quite sensible. But the longer 0624, which is 2,800 meters, is given a 1, so default figure is takeoff 1. That's your logic there. Very long runways like Sierra Alpha Echo Zulu, their runway 1129 is 3,300 meters, so that's actually given a takeoff 2. The shorter runway there, 1533, is given a 1. So there's your logic for how these are used. Okay, geometric path descent in approach phase only. I mentioned this with 10.6, and you recall I said that the geometric path descent in the approach phase, or geometric path descent for the entire descent was made mandatory in 10.6. They changed their mind and gave us the option in 10.7 to just switch it to either full, which is the whole descent, or in approach phase only, and that is changeable here on the FMCS perf factors. So it basically gave a little bit more control and flexibility to the airline. Again, I won't labour the point. We've been through this several times, but you can see the difference in the green dotted line is full, and the red line there is approach phase only. Higher idle descent profile. This was just a new model engine database to support an updated EC software version to use a higher idle descent profile. That's all that was. Bug fixes. 10.7 actually contained over a dozen significant bug fixes and the elimination of no less than 4 FCOM bulletins. I'll go through a few of those with you briefly here. So there was one which was on prediction errors. So 10.6 had a bug which incorrectly processed wind data for certain downstream legs, which could result in erroneous values of ETA and fuel remaining at those waypoints. This is obviously not good. It also affected the RTA function as well, and it was put down to an error in the sensed wind, leg length, and course change for downstream waypoints. Full details were given in this bulletin. I won't read out for you. Hopefully, you actually probably no longer have this bulletin as you got 10.7 or greater. What this also led to was accuracy improvements in the whole RTA function. Again, RTA was introduced with update 4 back in 1989. It was designed for en route operations, and it was actually intended to correct for differences between ETA and RTA when the aircraft was about 2 hours from the RTA location. It was never really designed for close-in changes. So if you're and the time, well, this time I seem to get this is when you check in with a new frequency, and they're saying, well, you've got an EAT of such and such. If you can cross a certain waypoint at or arrange to not cross a certain waypoint before a certain time, and you only get this information about 15 minutes out. So you will use the RTA function, but it was never quite designed for that. So with the revamp from the previous FCOM bulletin, improvements were made to the way these calculations were made, and the whole RTA accuracy was improved by modifying the method and frequency of ETA updates to give better control of RTA time in dynamic conditions, such as changing winds or when you're in the descent. So the whole RTA function was made much better with 10.7. Another change, or bug fix which was addressed, which was for holding patterns. So the FMC would, under certain circumstances, create unusually large holding patterns, and in each case that it was initially shown correct, but when either a deceleration was sequenced or the aircraft was established in the hold, it suddenly jumped and became larger than expected. And when LNAV was engaged, the autopilot flight director commanded very shallow bank angles in the turns, which would take you outside of the holding protected area, and hence you got the scratch pad message, unable hold airspace. So that was done. Again, the bulletin was issued. The workaround for this was don't enter an airspeed in the hold page, because that's what seemed to trigger this. This was addressed, and the whole holding process was revamped and recalculated by Smiths. So what was done was that they were all revised to use non-overfly entries and exits in place of what had been flyover entries and exits. If you do a non-overfly entry and exit, you can uh, stay within the protected area of the holding pattern. So it gives you better RMP holding, as the entries and exits don't take you beyond the holding pattern. And you can see I've got 3 examples there. I think the middle example is probably the best one, where you can see that the for the hold entry, the turn is actually it flies by rather than over the REI01 waypoint there to stay within the boundaries of the hold. So some good came of the original bug. It got a revision of the whole holding calculation, and holds were improved as a result of it. There was another bug which basically, that if you had a leg that exceeded 1,000 nautical miles, I mean, who does that? Then the FMC would fall over and fail. Well, there you go. I I I cannot think of a time I've ever used a 1,000 nautical mile leg, but if you ever did, that's what would happen. This one was perhaps a little more common in that there was a bug in which SIDS could trigger a software restart when using altimeter setting above standard. Again, I won't labour the point, because obviously this is all ancient history, but it's there. You can pause the presentation if you want to read up on it. But the bug fix was addressed. Okay, so 10.8. Now this was again, we got 2 years out of 10.7, which was good. Before 10.8 was introduced. Unfortunately, 10.8 proved to be so buggy that in just, what was that, 4 months, from Feb 2009 to June 2009, Boeing actually instructed the removal of 10.8 and the reinstallation of 10.7. And this also required the rollback of various sections of the FCOM Volume 1, 2, and the QRH. And there was a bulletin reversion to 10.7 or earlier released as a result. So this is quite a rare photo of of the NIDIM page of 10.8. Only got a fleeting glimpse at this in its short career. What 10.8 brought in, apart from the bugs, was performance data for Winglet 737-500s, and also optimum altitude calculations for all Winglet classics. The model engine database and logic was updated to support an enhanced 7B26 B2 engine rating. The nav database size was increased up to 16 megawords, which, as you know, is shown as 8192K words. Sorry, 16 megabytes, which is shown as 8192 words. Why on earth Boeing persist with using words instead of megabytes, I don't know, but there you go. And there were some improvements to engine out logic, and this was actually bug fixing some stuff from 10.7. And improving the engine out logic. So these are actually all listed in your FCOM, but the first 3 bullets there were basically just adding a 60 knot check. The last 2 bullets were adding the ability to clear the engine out condition in the FMC. So that's what those changes and tweaks were all about. Arming VNAV on the ground, you recall that this was brought in 10.7. There was a bug fix for this, which allowed it to be done with 10.8. and there was a bug fix for the FMC lockup when selecting a SID during a missed approach. This anomaly had actually existed since 10.0, but was not addressed until now, presumably because it was such a rare occurrence. But anyway, it was eventually identified and fixed here in 10.8. Okay, software exceptions. I mentioned earlier I would talk about these. It's a phrase that that the Boeing and Smiths use a lot, and it's in. I think it's in the FCOMs. It's certainly in the service bulletins and service letters. Right. So a software exception. It's defined as a disruption in the normal flow execution of the software code. Okay, well that's fairly bland and meaningless. In plain English, what a software exception is it's when the FMC is trying to resolve an unsolvable calculation. And if you're interested, then Google the phrase unsolvable calculation, and it'll probably take you to a Wikipedia page which lists these. And these are things that mathematicians love to find and try and solve. I guess it's things like, I'll try and give you a simple example. Dividing something by zero. You can't divide by zero. There you go. That's an unsolvable calculation. There are dozens more. And as I say, if you're interested, go Google it. It's stuff that'll make your head explode. Well, anyway, it makes the FMC explode as well. Not literally. It simply tries to restart, and if it tries to restart too many times and fails, then it will just shut off, which is fairly unhelpful to us trying to fly the plane. Anywho, these 6 software exceptions were sorted out in 10.8, and I won't read them out. The list is there, which was good. What was even better was the handling logic to software exceptions. So pre 10.8, a software exception would lead to a restart, and the FMC would shut down after 3 consecutive software restarts within 60 seconds. So now, really, if a computer has got a computation it can't solve, doing a restart, well, it may or may not solve it. If it's got the same computation on restart, it still ain't gonna fix it. It either needs different data or a different solution to sort this out. I mean, really, the idea that the 3 restarts would fix it, seems a bit crazy. But the point is, it can't go on restarting ad infinitum. So what it does is it just shuts down. However, from 10.8, the geniuses in Smiths revised the software exception handling logic to prevent a complete FMC restart in the event of most software exceptions. Hallelujah! So what happened was, if it got into a state where it found an unsolvable situation, instead of shutting down, it would go into downgraded mode. And in downgraded mode, what you retain are LNAV and the map. FMC predictions are halted, and VNAV is disconnected with a VNAV invalid performance message. In actual fact, for that, all you need to do is re-enter the cost index, and VNAV will come back. So effectively, you've got VNAV and LNAV and a map. So happy days. You've still got your you've still got your FMC to a degree, and you've still got, well, LNAV, VNAV, and a map. So things are nothing like as bad as they used to be. Other messages you might get are invalid modified plan or invalid inactive plan in case you tried to recalculate something on one of those two, or reload one of those two. Now, I should say that this improvement, whilst really good, it will actually not prevent all restarts, but it will prevent a lot of them, and it will prevent a lot of cases where the FMC would just shut down. So that was a huge bonus that came with 10.8. FMC disagree, and again this kind of follows on from the previous slides. It's all very well when you got one computer, but when you got two computers, like the man with two watches who never knows exactly what the right time is, you're always bound to get slight differences in calculations. So the FMC disagree message, which came in with 10.6, the logic has been updated to now remain displayed until a condition causing the message has been resolved. It used to disappear. How helpful was that? Also, FMCs are no longer checking for Mac and iOS miscompares on the ground, which again, you looking back at it in the cold light of day, you'd wonder why it would ever compare Mac when you're on the ground. But anyway, it did. Now it doesn't. If you get this message, standard procedure really, just monitor both FMCs closely, and the advice is, the strong advice is to limit approaches to single FMC only. Both FMCs should remain online, even with a disagree. Okay, so 10.8A. This was rushed in to fix the very short-lived buggy 10.8. It was introduced in May 2010, and 10.8 actually had a surprising longevity. New features with this were a new FMC disagree vertical alert message during VNAV path descents. The cause of this was a vertical deviation, FMC airspeed or FMC Mach value disagreement between the FMCs by more than the allowed tolerance has occurred, and long enough that all attempts to resynchronize have failed while the aircraft is in a path descent. The display will be inhibited when you're in the approach nav environment because it wants to prioritize things for you. Corrective action for this: don't move the FMC source select switch, just monitor crossing altitudes to ensure compliance with the approach. Another one is the full climb thrust after a derated takeoff thrust is uploaded by ACARS on aircraft that have got the a zero performance code option. So again, a bit of a technical one, that, but it does allow this to happen. Another bug fix was for VNAV approaches. There was a bug which would command the aircraft to descend below the expected path on approach. This was really the main reason why 10.8 was pulled so hastily, and this was addressed with 10.8A. Other bug fixes were VNAV path descents into airports above 10,000 foot elevation would cause the FMC to fall over, and left and right FMCs commanding different descent speeds. To be fair, the different descent speeds weren't particularly far out. It was only a couple of knots, sorry. But it did happen, and it was a source of mild amusement for us. The replacement, after 13 updates to update 10, or the update 10 family in 13 years, so that's one a year, update 10.8A really quite impressively remained the current update for 5 years until March 2015, without any further updates until it was eventually superseded by update 11. Amazingly, for such a complex piece of software, it introduced only one minor bug, and note that some updates had introduced over a dozen, and that bug would give intermittent operation of the FMC altitude intervene function if the approach altitude restrictions were well, if all of the approach altitude restrictions were deleted, and that was easily fixed with update 11. So they got there in the end. 10.8A was a huge success, and was the current FMC software update for, I say, 5 years. So that was a real result. So that's it for this video. The next one, I will cover update 11 to update 14. As always, if you've enjoyed this video, please give it a like, subscribe, and if you're feeling flush, please get a copy of the book. Thanks very much.